Hey everyone, Morgan here. So we're starting off a new unit. It's called Thermochemistry. We are on page 1 of the lecture outline. And for the first few pages, we're going to lay the groundwork for this chapter. And it's going to involve some vocabulary. And vocabulary may not be the single most exciting thing that we are doing this year, but it is a very necessary thing for this chapter. Okay? We'll start off with what is the easiest word in science, in my opinion, and that is matter. Matter is anything that has mass and takes up space. Now, I have jokingly in class said that you can get away with just saying stuff. And stuff is a pretty good way to think about it. We're talking about anything, okay? If you can touch it, hold it, taste it, see it, feel it, it's matter. It's made up of stuff. And then we're going to transition to what is the hardest word in all of science to define, and that is energy. Now, if you want to get points on a test, you can write that the ability to do work or produce heat is energy. Okay? There are a lot of types of energy, and not all of them fall within the same definitions, which is what makes this challenging. Okay? So really, this entire unit is going to be us looking at interactions between matter and energy. Now, energy, the way we're dealing with it in this chapter, takes two forms, kinetic and potential. Kinetic energy is energy that is due to motion, and potential energy is stored energy. Now, in physics, we would say energy due to position, and often we would actually call that the gravitational potential energy. That's not too relevant for what we're doing, okay? Energy is stored in chemical compounds in bonds. Breaking bonds requires energy, and then when bonds are formed, energy is released. So energy in to break the bonds, energy out when they form, and the difference in those energies is going to become very important for what we're going to be talking about. All right. Now, temperature. I'm hoping you actually remember this from back in the gas law unit. Temperature is a measurement of the average kinetic energy of the molecules that make something up. If you want to shorten it to two words, you could say temperature is molecular motion. Heat is a transfer of energy between two objects that are at different temperatures. So let's imagine that I have two blocks of iron. The first block is at room temperature. The second block is glowing red hot. Now, what's the difference between the iron in the first block and in the second block? Nothing. Iron is iron. It's just that the iron atoms that are in the hot block are vibrating or jiggling much faster than the ones that are at the room temperature block. It's really just a discussion of molecular motion. So when I bring those two blocks together, what happens is that some of the kinetic energy from the higher temperature one moves into the lower temperature one, which means that the atoms of iron in that colder block will start vibrating faster and its temperature will go up. And at the same time, atoms in the hotter block will slow down and their temperature will go down. Okay. Work. We don't actually deal with the concept of work all that much in honors chem, but I want you to have the definition of it. It is a force acting over a distance. And that's a good definition from a physics class, but in terms of what we do here, there's not a whole lot you need to know about work. Now, the system. The system is going to be our main focus for this entire chapter. The system is what we focus our attention on. Now, in a high school chemistry class, Almost all of our thermodynamics experiments are going to happen inside of a styrofoam cup. The reason for that is that a styrofoam cup is an insulated chamber. It is not perfect, but it does prevent heat from flowing in or out over a short period of time. And that makes that a really important thing for us. So the system is what we focus our attention on, and the surroundings are anything that can have an effect on our system. Now, in that styrofoam cup, maybe we're reacting an acid with the base and it's warming up. Now, if we're doing it outside on a bright sunny day, the sun is definitely part of our system, okay? But if we're doing it inside and we're we're just wearing a yellow t-shirt, that yellow t-shirt has nothing to do with the experiment. Even though it's adjacent to it, it's not part of the surroundings because it does not have an effect on our system itself. And those are the definitions for page 1, and we will hit page 2 in the next recording.